Number 4, let X equal the amount of money you make in 1 month selling candy bars and Y equal the amount of money you make in 1 month selling soda, where Y is greater than X. So first off, we know that you're going to end up selling soda, or you're going to make more money off soda than candy bars, right? So what are these expressions? What are they all about? If you do Y minus X, you're taking the money that you make selling soda minus the money that you make selling candy bars. So this is the difference. This is how much more money you make off soda than candy bars, right? So you write that. I'm saying how much more money you make off of selling soda than you make off candy bars. That would be my interpretation of that expression. This one, X plus Y, that obviously you're taking this amount of money from candy bars and the amount of money from soda and putting it together. So if I were to say that concisely, I would say the total amount of money you make in 1 month selling soda and candy bars. Now this one, we're doing times 3 each, right? So I'm talking about if this was in 1 month, if I multiply both by 3, then we're talking 3 months. So that would be total amount of money I make selling soda and candy in 3 months. So then circle the expression above that's the largest and explain how you know. Well, obviously this one's the largest because the difference in the two of them is going to be smaller. The sum of the total in 1 month is going to be smaller than the total in 3 months. So knowing what they mean is going to help you figure out which one is always the largest. We're going to go on to number 5 here. Are the expression pairs below equivalent? Write yes or no beside each pair and then explain your reasoning. So are these equivalent? There's a couple of ways you can do this, but I'm going to just use algebraic. You could plug numbers in. So I could plug a 1 in for an X and a 2 in for a Y and see if they give me the same answer, right? But then you want to check a couple of different numbers. But using algebra is a way to make sure that you always do this. Now, to have this to the 3rd power, this is already simplified. But if we can get both of them simplified, we'll see if they're the same. So this really means raising this to the 3rd power really means writing this 3 times, right? Multiplied by each other. So we can see very clearly that we've got 3 times 3 times 3. That would be 27. We've got x times x times x. That would be x to the 3rd. And here we've got y squared times y squared times y squared. That's really like, if we write that out to the side, that's like 6 factors of y altogether. So 6 factors of y. So this is really 27 x to the 3rd y to the 6th, and this is 3x to the 3rd y to the 6th. So the answer is no. And the reason why is because this didn't raise the 3 to the 3rd power, right? I want to point out that here you could have used a faster rule where you know you have to multiply exponents. But I just want to point out that that's part of the problem when you do things like this, because people will forget to give the 3 to the 3, right? They will forget to raise this 3 to the 3rd power. So sometimes writing it out like this instead of memorizing the rules is an easier way to remember, oh, I do need to do the 3 times the 3 times the 3. Okay, this one I'm looking at and I automatically know the answer is no. And the reason is because x minus 5 squared is really x minus 5 times x minus 5. And here the difference is this person just did squared and squared, right? But that's not the same thing as doing x minus 5 times itself. Here you need to do the distributive property, right? And those middle terms end up really making a difference, right? So also notice what happens here is that negative 5 times negative 5 is a positive 25. So there's 2 things that went wrong here. Then when we combine like terms, we've got x squared minus 10x plus 25. So are these alike? No, because this one you need to multiply x minus 5 times itself, and that requires distributive property. On this problem right here, are these 2 terms alike? The answer is no. And the reason is because you don't add fractions by adding their denominators. You need the same denominator. Okay, so on this one, I'm not even going to go through the algebra. Let's just pick a number. Let's pick 1 and plug it in for x. So let's try x equals 1. So I've got here 1 over 3 times 1 minus 2 over 2 times 1. And over here I've got negative 1 over 1, right? So clearly this one's going to be negative 1. This one's going to be 1/3 minus 2 over 2, 1. So that's negative 2/3. You can do this with your calculator. I'm doing it by hand. So here, when I plug 1 in, I get negative 2/3. Here, when I plug 1 in, I get negative 1. So clearly the answer is no. So see, here we used algebra to prove that they weren't equivalent. Here, I used substitution to prove they weren't equivalent. So you would explain that reasoning. And it's why the explanation is important, because you might use a different method for each. You could have also put these into your graphing calculator, y1 and y2, looked at their graph to see if they were the same, or looked at the tables to see if they were the same. Last one, these two, is 7x to the 5th plus xy to the 5th, the same. And here, this is plus a 1, right? So this is 7 plus 1, which would be 8xy to the 5th. They are like terms, but this one would have to be a subtraction for these two to be the same. So they're very close, but it would need to be subtraction for them to be the same. So none of them are the same.